If you take the elements fluorine, aluminum, and chlorine, you can make an ionic compound. The reason why is because aluminum has a 3+ charge, and fluorine and chlorine both have a 1- charge. Let's take a look at a more challenging example. If you take the elements phosphorus, potassium, and calcium, it will take 1 calcium and 1 potassium to make the charge equal to 0. The reason being is because calcium has a 2+ charge and potassium only has a +1 charge. So together, they cancel out phosphorus, which has a 3- charge. When naming molecular compounds, you must use a simple rule, and that rule is to put a prefix in front of the element's name. The prefix also corresponds with how many atoms there are in that compound. For example, if you have 1 element, you say mono. If you have 2, you say di. If you have 3, you say tri. Now moving on to SPON. SPON stands for the elements sulfur, hydrogen, phosphorus, oxygen, and nitrogen. The H also stands for halogens. The reason SPON exists is to tell you all the elements that are polyatomic. This means that in their natural state, they exist not as one, but in higher numerical values. All elements that are part of SPON exist in 2s except for phosphorus, which exists in 4s, and sulfur, which exists in 8s. Last but not least, we have common molecules. Common molecules are basically complex compounds that are so frequent we give them different names. For example, glucose is a sugar that you get from the different foods that you eat. But you don't hear people calling glucose C6H12O6. That is because it is such a common thing that we give them a common name.